Hello, good morning, good afternoon, good evening, Bacha Pati. Today we are going to learn Fajans rule in chemical bonding. Let's start Fajans rule without wasting your time. Fajans rule. Fajans rule. Here, what Fajan is going to explain means, first of all, ionic bonds will be there. Now, in ionic bonds, somewhat covalent character will be present. Ionic bonds, in ionic bonds, somewhat covalent character will be present. That this rule is going to explain. Covalent character, covalent character in ionic bonds. Fajans rule is going to explain covalent character in ionic bonds. First of all, ionic bonds. Ionic bonds we all know that ionic bonds are formed by transfer of electrons from metals to non-metal. Transfer of electrons from metal to non-metal. This is called ionic bond. While coming to your covalent bond, we have already read that covalent bond is formed by sharing of electrons. Covalent bond is formed by mutual sharing of electrons. That is called as covalent bond. Mutual sharing of electrons is called covalent bond. Here, first of all, no bonds are perfectly covalent and perfectly ionic. They will have both ionic and covalent character in that. That this rule is going to explain. Note down this first of all.
La, la, la. La, la, la.
First, we need to know that ionic compounds we all know that ionic compounds are more soluble in water. Like your NaCl, sodium chloride, which is highly soluble in water. For example, we can take some amount of salt. If you add to the water, it will become our solution, salt solution. Salt will dissolve in water. That is, ionic compounds are more soluble. While coming to covalent compounds or covalent bond, they are not soluble or insoluble. Ionic compounds or ionic bonds are more soluble in water, but covalent bonds are less soluble or insoluble in water. And next point, they have more melting point and boiling point. I have written melting point in short form MP and boiling point in short form BP. While coming to covalent bonds, they will have opposite to the ionic compound, they will have low melting and boiling points. They will have low melting and boiling points in covalent bonds, and while coming to ionic bonds, they will have high melting and boiling points. And another one thing, limitation. Limitation of Fajans rule. It has one limitation. Fajans rule has one limitation. It is a qualitative law. Qualitative law. Qualitative means we can compare which ionic compound is having more covalent character or more ionic character, but we cannot give percentage. For example, NaCl and KCl. We have two ionic compounds. Here we can check, we can compare which has more ionic character and which has less ionic character and covalent characters also. But we cannot tell in terms of percentage how much. For example, we cannot tell NaCl has 80% covalent character and 20% KCl has covalent character, like that we can't tell. We can check or we can compare. We can compare covalent character with by using two ionic compounds, but we cannot calculate in terms of percentage. That is the one limitation of Fajans rule. No doubt. Now we are going to learn ionic compounds. In that we all know that it will have more solubility. That is, ionic compounds are more soluble in water and high melting. That is, more melting and boiling points. And another one thing, while coming to solubility, if solubility is high and melting and boiling points are high, then covalent character will be more. This point we should remember. While solubility along with melting and boiling points are more, covalent character will also be more. We can tell like this: if covalent character, in short form, covalent character is more, solubility will also be more, and melting and boiling points will also be more. This is one shortcut to remember the solubility and melting points and covalent character of ionic compounds. Next one, first let this be one cation and another one this be anion. We all know that in ionic compounds, transfer of electrons takes place from metal which having positive charge to the non-metal which is gaining electrons, means it will have negative charge. Here let the electrons be electrons. This is cation, this is anion. Here anion which is in spherical shape, like your circle, which is in spherical shape, here this shape will be changed or it will be deformed due to these electrons are there now. Electrons on the anion which are present, they start moving towards the cation in this manner. Electrons on the anion, they will start moving towards the cation. It means cation is trying to pull the electrons which is present on the anion. It means here cation has somewhat electrostatic, that is force of attraction. That is, like charges repel, unlike charges attract, right? Force of attraction, to that force it is it is taking these electrons towards itself, and the the size of the anion along with the shape, it will be changed. See here, I will write positive charge, that is cation, it will be like this only, but the shape of the anion, it will be somewhat changed. It is less unlikely. It will become almost, it will be changed like this. Here electrons near to the cation. Here cation is trying to attract the electrons towards itself. It means this anion shape is there now, it has been changed. That is, I have written here anion. Here the cation is trying to attract the electrons which is present on the anion, so the shape of the anion will be deformed, means it will be changed, and during this change the poles will be created. During this change in the shape, due to the force of attraction of cation, the shape will be changed of anion, that creates poles in the anion. Poles means charges, that creates charges in the anion. Here, these other charges. This process is called polarization. This process is called polarization of, we are doing polarization of anion, right? Polarization of anion. I will repeat again. Cation, which is in small in size, and anion, which will be bigger in size, which will be big. So cation here, first of all, which is positive, which has positive charge, and anion, which is in negative charge. Like charges repel, unlike charges attract, right? This positive, that is cation, try to attract the electrons which is present on the surface of the anion. So the shape of the anion will be changed or deformed like this. It will look like this, and during this process charges will be produced, that is poles will be produced, and this process is called polarization, and we are doing this process for anion, right? So polarization of anion, this process is called polarization. So polarization of anion. And another one thing, cation has the power to attract the electrons, right? That power is called as polarizing power. Polarizing power. The cation having power, that is, it is having the power to attract the electrons from the anion. That power is called as polarizing power. Note down, students. Another one thing, if 2 points to be remembered here, point number 1 and point number 2. If polarization of anion is more or increased, means covalent character. Polarization of the anion is more, means covalent character will also be more. If covalent character increases, means polarization of anion also increases. And second point, if polarizing power of cation, polarizing power of cation increases, means covalent character also increases. Covalent character also increases. Here 2 points to be remembered. These are the 2 main important points. If polarization of the anion increases, means polarization of the anion is increased, means covalent character will also be increased. And second point, if polarizing power of the cation is increased, means covalent character also increases. These are the 2 important points to be remembered. Note down, students. देखिया जब बदलती देखिया क्या बदलती देखिया. Next one, properties. While coming to first one, charge of cation. First property, charge of cation. If the charge of cation, that is cation, if the charge of cation is more, if charge is more, it attracts more electrons, that is it attracts more electrons towards itself. If the charge is more, means the charge of the cation is increased, means or more, means it attracts more electrons towards itself. In this case, covalent character also increases. Covalent character increases. If charge of the cation is more, means covalent character also increases. If charge of the cation is less, means covalent character decreases. Vice versa. Second one, size of the cation. Size of the cation. In size of the cation, if the size of the cation is big, size of the cation is big, so it means covalent character. If size increases, means covalent character decreases. You remember this point. If size increases, size of the cation increases, means covalent character decreases. Then next, for example, we can take one example here: lithium, sodium, potassium. Here I have taken 3 metals. For example, as we know, as we move down the group, size increases. Size increases. As we move down the group in group 1 elements, size increases. So potassium will have more size here. Here lithium will have less size. So order of size will be lithium will have less size. So lithium has less size and more covalent character. CC, covalent character. Lithium has less size and more covalent character. And last one, third one, pseudo noble gas configuration. Pseudo noble gas configuration. First of all, noble gas configuration means it NH2NP6. Outermost shell will be NH2NP6. NH2NP6. But here pseudo noble gas configuration NH2NP6 ND10. NH2NP6 noble gas configuration. This is noble gas configuration. Here pseudo noble gas configuration means NH2NP6 ND10. ND10. This is called, I will write in short form, PN, first letters PNGC. PNGC, pseudo noble gas configuration. Here NH2NP6 ND10 is pseudo noble gas configuration. First of all, pseudo means fake or false. Pseudo means fake. It is, I mean to say that fake noble gas configuration is, that is called pseudo noble gas. Pseudo means fake. Noble gas configuration means it should have this type of configuration, NH2NP6 ND10. Pseudo noble gas configuration means NH2NP6 ND10. Example, copper atomic number 29. Copper atomic number 29. We know that electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2, totally 10, 20 electrons. Remaining next comes 3d9. This is the ground level electronic configuration. While coming to excited state, in excited states we know that one electron will jump to the excited state. Electronic configuration will be 1s2, 2s2, 2p6, 3s2, 1s2, 2s2, 2p6, 3s2, same 3p6, 3d10. Here Cu plus means one electron will be removed. One electron will be removed from your S shell. First we will remove electron from the S shell. Next we will go to the remaining shells. First we are removing one electron from the S shell. 3d10. We have added one electron to the, first we have added one electron to the 3d, that is 3d10, and remaining 4s0, right? One electron removed and one electron added to the D shell. See here 3s2, 3p6, 3d10. It looks like NH2, 3s2, NP6, 3p6, 3d10, ND10. This is called your pseudo noble gas configuration. Pseudo noble gas configuration means it should have outermost shell, that is NH2, NP6, ND10. This is one example for pseudo noble gas configuration. Similarly, AG, that is AG plus, will have 4s2, 4p6, 4d10. Like copper, Cu plus has 3s2, 3p6, 3d10. I will write here. Ag plus will have 4s2, 4p6, 4d10. Pseudo noble gas configuration. While coming to Au, gold, it will have 5s2, 5p6, 5d10. First copper, Cu plus will have 3s2, 3p6, 3d10, and Ag plus silver will have 4s2, 4p6, 4d10, and Au, gold, will have 5s2, 5p6, 5d10. These are the some examples for pseudo noble gas configuration. Another one thing, like your zinc, Zn plus, cadmium plus, mercury, these 3 will also has these 3 cations. Cation means here it has positive charge, right? Cation. These 3 cations will also show pseudo-noble gas configuration, and the cations which are showing pseudo-noble gas configuration, they will have more covalent character. The cations which show pseudo-noble gas configuration PNGC, pseudo-noble gas configuration will have more covalent character. Important point. The cation which shows pseudo-noble gas configuration will have more covalent character. This is about pseudo-noble gas configuration. I will repeat again. Pseudo-noble gas configuration means outermost shell NH2 NP6 ND10, that is called as pseudo-noble gas configuration. Example, here I have taken copper Cu plus, its outermost shell will be 3H2 3P6 3D10. It looks like NH2 NP6 ND10 3D10. This shows pseudo-noble gas configuration. This is one example for pseudo-noble gas configuration, and it is obeying pseudo-noble gas configuration means its covalent character will be more. So Cu plus has more covalent character, and similarly Ag plus and Au plus will obey pseudo-noble gas configuration, and these 3 cations also obeys pseudo-noble gas configuration. The cations which obey pseudo-noble gas configuration will have more covalent character. That is the idea here. Note down. Next, we are going to talk about anion. Cation, we discussed 3 properties. Now we are going to discuss about anion. In anion, polarization is a process occurring in anion. That is, cation will try to attract the electrons towards itself. That is, size and shape of the anion will be changed, right? That is the process, and during that process poles will be created. That is negative charge. That is the process is called polarization. Now in this we have totally 2 properties. First, charge of anion and size of anion. We have 2 totally. Let's learn one by one. First I will take size. While coming to size, if the size of anion is more, means it is unstable. More size means it is unstable. It can lose easily electrons, and less size means it is more stable. That is, it can't lose electrons easily. So here, this is another one, anion, which is in less size. This has only small size. This cannot lose electrons easily. If size is bigger means it can lose electrons easily. That is unstable. More size means unstable. Loss of electrons. Lose of electrons is easy. Lose of electron will be easy. In this case, covalent character. While coming to covalent character is more. In this case, covalent character will be more. Next one, charge of anion. While coming to charge, if the charge of anion is more, like this, if the charge of anion is more, the charge of anion is more means covalent character also be more. Charge is more means covalent character is also more. This is the 2 points in which in polarization, that is anion, we have read first point, size of anion. If the size of the anion is big, means it can lose electrons easily. If the size of the anion is small means it cannot lose electrons easily. In this case, if more size means unstable and loss of electrons is easy, in this case covalent character will be more. And while coming to charge of anion, if the charge of the anion is more means covalent character is also more. If the charge of the anion is less means covalent character is also less.
Done.
Okay. Now let's take some examples and compare which has more covalent character and which has more solubility. Example 1, we are talking about more covalent character. Example, NaCl, KCl and RbCl, rubidium chloride. Here cation are different, but anion Cl minus, Cl minus, Cl minus. Here cation is different, but anion are same. I'm sorry, cation is different, anion is same. Okay. See here, Na plus, K plus, Rb plus. We all know that as we move down the group, in first group, size increases. So Na plus will have less size. So more covalent character. The cation which has less size, it will have more covalent character, but while coming to rubidium, it is bigger in size and it will have less covalent character. More covalent character. Another one example, BeCl2, MgCl2 and SrCl2. This is regarding to the group 2 elements. Here anion is same, while coming to cation it is different, Be2 plus, Mg2 plus, Sr2 plus. Here beryllium, magnesium, strontium. Okay, here as we move down the group in second group elements, size again increases. Size increases means first elements like beryllium, here it has less size, it is in beginning, so less size, and strontium Sr plus 2 will have more size. And we discuss about beryllium, that is it has less size and more covalent character. More covalent character. Here, between these three examples, these three compounds, here beryllium will have less size and more covalent character. But while coming to SR plus 2, that is transition plus 2, it will have more size but less covalent character. Okay, note down, students.
La la la. La.
Next example, we are going to take about solubility. That is, ionic compounds are more soluble in water and covalent compounds are less soluble in water. For that, we are going to take few examples and we are going to solve. Now, solubility. Number 2, solubility. Ionic compounds more soluble. You know that more soluble means covalent character will be more. Example 1, BeF2 MgF2. Here, first of all, see here, cation is different, beryllium, magnesium, but anion is same, fluorine, right? Now take beryllium and magnesium. They belong to same group. That is, as we move down the group, we know that size increases, but we are not talking about size here. Sorry. Beryllium and magnesium, here between these two, as we move down the group, size increases. So beryllium will have less size means more covalent character and more soluble. Here beryllium is having less size while compared to magnesium, so it is more soluble. More soluble means more covalent character. More covalent character. Example, let's take another one example. CaCl2 and CaBr2, calcium chloride and calcium bromide. Here cation is same, but anion is different. Between chlorine and bromine, one order you must know in halogens: fluorine, chlorine, bromine, iodine. As we move down the group, here also size increases. As we move down the group, size increases. So chlorine will have less size. Less size means more solubility. Solubility is more and more covalent character. More covalent character. But bromine, which is bigger in size, so it has less solubility and less covalent character. Note down, students. Next, third example. Example 3, NaCl and CuCl. See here cation is Na plus, Cl minus is anion, Cu plus, Cl minus. Here we are going to deal with pseudo noble gas configuration. Pseudo noble gas configuration means outermost shell NH2, NP6, ND10. Remember this, and we write that copper Cu plus cations like Cu plus, Ag plus, Au plus, and Zn plus, Cd plus, and Hg. Hg plus will have more covalent character. The cations which shows pseudo noble gas configuration, they will have more covalent character. Here Cu plus, we know that it follows pseudo noble gas configuration, so its covalent character will be more, means solubility will also be more. Solubility is more, means covalent character Cc is also more. This is one example regarding pseudo noble gas configuration. Let's take another one example. KCl and AgCl. See here, between K, here first of all cations are different, anions are same. K plus Cl minus, Ag plus Cl minus. We know that Ag plus, Au plus, Cu plus, they follow pseudo noble gas configuration, so their covalent character will be more. So here we have Ag plus, that is silver ion. Here it has more covalent character, more. Cc means covalent character in short form. More covalent character means more soluble. That is solubility is more. Here silver Ag plus, otherwise Au is there, means Au plus is there, means it also obeys pseudo noble gas configuration. So more covalent character means more soluble. These are the few examples regarding solubility. Last one, more solubility. More soluble means, that is ionic compounds. If compounds are more soluble means covalent character will also be more, but your color imparting nature will also be more. See here, sorry. If covalent character is more, means less soluble. One thing you remember, while coming to color, solubility is less, means more covalent character, and your color imparting nature will be more. If solubility is less means covalent character will be more, and color imparting nature in this case will be more. For example, let's take one example. AgF, AgCl, AgBr, and AgI. Between these four, which has darkest color, we need to identify. Between these four compounds, AgF, AgCl, AgBr, and AgI, which has the darkest color, how to identify? First of all, these and all are halogens, right? Fluorine, chlorine, bromine, iodine. In halogens, as we move down the group, color imparting nature increases. Color imparting nature increases. Color imparting nature increases. Means iodine will have darkest color. See here, iodine. As we move down the group, iodine, that is color imparting nature increases, means iodine automatically has the darkest color. So this will have darkest yellow. Darkest yellow in color. As we move down the group, we know that size, that is color increases. So iodine will have darkest yellow color, and while coming to your AGBR, it will have yellow. It will have yellow in color, and while coming to your AGCl, that will have white. It is white, and AGF is colorless. See here, first of all, as we know that if you move down the group, color imparting nature as we move down the group increases, right? See here, first of all, darkest yellow, dark color, it converts